We are talking about triangle congruence today. In the last lesson, we talked about triangle similarity, and this time we are not just similar, we're actually going to be congruent. Little fun fact for you here. You know, the similarity symbol is this little squiggle. The congruent symbol is equal with that above it. And, you know, here's a fun little fact for you. If two triangles are similar, it means that they have all corresponding angles congruent, right? If they're equal, what does that mean? It means all their corresponding sides are also equal. And you know what that means? That the triangles are congruent. So isn't that kind of cool that that is how we use that symbol? That's kind of the breakdown. Congruent triangles are still similar. They're similar and they're equal. That makes them congruent. It's kind of a little fun fact for you there. So there are several different triangle congruence postulates. I count 1, 2, 3, 4, 5. Okay. And all we're going to be doing with these postulates is looking at a pair of triangles, like you can see on the right over here, and trying to identify which postulate shows that they are going to be congruent. So our answers are going to be SSS, which stands for side, 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 SAS, side, angle, side, ASA is angle, side, angle, 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 side, and then HL. And we'll talk about what that means. You know, there's a couple here that we do not have, right? One of them being AAA. So that's not anything that works. Triangles are not congruent if you know all the angles. And there's another one that spells a bad word if we looked at it this way, right? That also does not work. So not every combination of S's and A's is going to be a triangle congruent postulate, but I'll explain to you what these do mean, all right? So if you've got two triangles and you know that all three sides of one are congruent to the other, we say they're congruent by side, side, side. If you're writing notes down, what I want you to do is go ahead and stop this video, get out a sheet of paper, and write triangle congruence postulates and theorems. The first one I want you to do is write SSS. And if you need to, I want you to write what that stands for, and it's side, side, side. Then I want you to write down both of these triangles. You don't have to write all that stuff, but draw these two triangles as an example of what that means, okay? All right, next is SAS. That stands for side, angle, side. And what it says that this postulate is if two sides and the included angle. We talked about that on the similarity lesson, where the angle has to be between the two sides, or the two sides make the angle. You see how that's working? That's called an included angle. So if you've got two sides and the included angle of one triangle, if that is congruent to two sides and the included angle of another triangle, they are congruent by side, angle, side. Go ahead and write that out as an example for side, angle, side. Then we're moving on to the next one, that's ASA. Okay, so just like SAS, side, angle, side, the angle is included. Now we've got two angles, and we want a side that's in between those angles. Okay, so two angles in the included side. So you can have an included side. If those congruent to another triangle that has two angles in an included side, then those are congruent. So we've got angle, side, angle. See how it goes, bam, 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 right in a row. Same thing on this one, angle, side, angle. All right there connected together. All right, so that's angle, side, angle. Go ahead and pause if you need to write some things down, right? AAS, angle, angle, side. Well, what's the difference between angle, side, angle, and angle, angle, side? Angle, angle, side, the side is not included. So the order of the letters lets you know which one you're dealing with. So if that S is between those two A's, you know the side's got to be between the two angles. If the A's are together and then the side, that means that side does not have to be between those two angles. So look at this. You've got two triangles together right here. Do you see this one side that they both share? That side was also congruent to the other side in that right, not a right triangle, but in that triangle. they share that side, so it's congruent to itself. So we can say AAS for that one. All right, and then the last one, we got to talk about some pieces of a right triangle. So let's go over here and kind of just have a little discussion about that. It's been a while since we talked about right triangles. Remember, right triangles have a right angle. And what is the side across from the right angle called? The hypotenuse. All right. Now, each one of these sides that actually are forming the right angle, they are shorter than the hypotenuse, and we just call those legs. They don't have a special name. They're just, each of them are called legs. So for the hypotenuse leg theorem, we just call it HL. And it says if the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another, then they're congruent using HL. Well, I only see this side and this side labeled. Now in that triangle, that's a leg. If you look upside down in that triangle, that's a leg. So what else is congruent in this picture? The side they share, which is the hypotenuse, and it is going to be congruent to itself. That actually has a name. I've said it twice. So let me tell you what that means. It's the reflexive property. It may not be a bad idea to jot that down. And that's when a side is congruent, or an angle is congruent to itself. Okay, so if you see a side that's shared in one of these pictures, what we're going to do is we're going to mark that on the picture. And all we're doing in this lesson is looking at pairs of triangles and trying to determine which one of these postulates will let you know, or theorems, that they are congruent. All right, so we're just going to do some examples here. Go ahead and pause this video if you want to go ahead and write these down. And I have also attached this file to Classroom. If you have the option of printing this out, that would save you a little bit of writing, but writing it down is going to help you no matter what. All right, so go ahead and pause if you need to write these down. All right, we're back. The directions say to determine if the triangles are congruent. If they are congruent, write the triangle congruent statements. That means triangle whatever is congruent to triangle whatever, and name the postulate or theorem. If not, write not enough information. Okay, so here we go. First one. Now before we do that, let's write all of our options down. If you've got your paper there, you don't need to do this necessarily. Is that all of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or sorry, only 5 choices. Okay, so in this first example, I see 2 angles and a side, and it's not in between the angles. It's not here, it's LJ and SR. So I know it's not side, side, side. I know it's not hypotenuse leg, because that has to be a right triangle thing. Now it could be angle, side, angle, or angle, angle, side. I know it's going to be angle, angle, side, because the side is not between the angles, it is outside. It's like not in their little club. All right, so the congruent statement, let's start with the one on the left. So KLJ is congruent to, let's see, T corresponds to K, S, and then I believe that's an R. I wrote on it. Now I can't see it. Is it an R? I don't know. We're going to pretend it is. Okay. All righty. Check. That one's done. All right. Moving on to number 2. If you want to, go ahead and pause and try it yourself, and then I will come back. All right. So for this one, I see 2 sides and an angle that's in between them. So you go to your list. The only option that has 2 sides only would be side, angle, side. And it's included, it's in between there, so I know it is congruent. Okay, pick which triangle to start with. How about E, G, F? It's congruent to triangle, let's see, A, and if I go in the same order, I need to go B next and then C. And you can write these in any order you want to. I'm just trying to pick one and go with it. Okay, number 3. First thing I want you to do, when you see 2 triangles that are joined together, go ahead and mark that they are congruent somehow, because that side that they share, that is, because it is part of the congruence. It works. All right, so we've got two triangles. They share a side, and all three sides are labeled congruent to the other. So this is a for sure side, side, side triangle similarity. So let's do WZY is congruent to triangle WXY. All right. Moving on to number 4, I see two sides on each triangle, and that is it. Don't know anything about any of these angles. Is there enough information? No, there's not. So not enough info on this one. We cannot form a conclusion, and they are not congruent that we know, so we're just going to be safe and not say so. All right, number 5, we've got an angle, a side, and an angle in that order. Angle, side, angle. See how these markings match up with E and S? The side, ST, corresponds to EC, and then angle T is congruent to angle D. And it's in that order: angle, side, angle. So yes, these are congruent by angle, side, angle. So the triangle congruence, we could say STR congruent to ECD. And again, you can write the triangle congruence statement a different way. I'm just doing it the first way I notice. Okie dokie. Number 6, okay, I see right triangles. If you see right triangles, I would probably put hypotenuse leg as an option, maybe. We don't necessarily know, but it could be an option. And then I do see two sides labeled. Okay, so maybe it's not HL, because what we have here is side, angle, side, side, angle, side. And the hypotenuse is not labeled, is it? So it can't be HL. It's actually just side, angle, side. But you need to consider HL as a possibility when and if you do have right triangles. So SQR could be congruent to, we'd have to say LMN. I made sure I put that right triangle in between those letters both times. So be really careful writing that congruence statement. You want to make sure you do it in the right order and that you're putting corresponding things together. For number 7, I see another set of right triangles. Now, if that's 90 degrees, this is also going to be 90 degrees because that's a straight angle. That side is going to be congruent to itself. And the hypotenuse is labeled across from the right angle on both of them, and so is one of the legs. So this is the HL problem. Let's do ABC congruent to CBD. That works. One more. Let's see what happens. We've got, a side, and an angle that's not included. Now, some people might look at it and say ASS, and we know that's not going to work. The one that spells a bad word is never, ever going to be a correct choice. Okay, that's not a triangle congruence. And we wouldn't even say that anyway. We would say side, angle. And side, angle, now side, angle, side works, but not SSA, right? So that doesn't work. So this is not enough info again because we don't really know. We can't use side, angle, side because the angle's not between them. If it was X and B, yeah, we could, but it's not. All right. So go ahead and try to practice figuring out the congruent triangles and writing congruency